attribute. It's the ordinal attribute. It's the ordinal attribute. So for ordinal attribute, for object 3 1, so we are comparing object 3 1. So in that way, if we go with like the comparison, the answer is 0.5. Answer is 0.5. So in that way, the answer is 0.5. So we have considered answer as 0.5. So we multiplied it by 1. We multiplied it by 1. And then the third type of attribute is numeric attribute. Third type of attribute is numeric attribute. So where we have calculated the dissimilarity matrix for object 3 and object 1. So 64 and 45. So for those values, here this is like for the test 3 output. This is the value of the test 3 output. So where the answer is 0.45. Answer is 0.45. So here we have considered 0.45 multiplied by 1. So in that way, now as there are 3 attributes in the sample data sets, so number of attributes are 3. That is test 1, test 2, test 3, of which first attribute is nominal attribute, second attribute is ordinal attribute, and third attribute is numeric attribute. So of which we have taken the output of the dissimilarity matrix. We are just expected to replace the values from the dissimilarity matrix output. So we have replaced the values from the nominal output from the ordinal output and from the numeric output basically. So in that way, and what we are expected to divide, so how many attributes are there? So 3 attributes are there. So we are dividing it by 3. And in that way we are calculating the answer. So dissimilarity matrix, or like the distance measure based on the mixed attribute for the object 3 and 1, the output is 0.65. So in that way, this output is calculated. So on a similar line, if you want, you can try for this also. This is like what? 3 4. This is what? 3 4. So in that way, if you calculate, the answer will come as like the 0.71. The answer will come as 0.71. So in that way, dissimilarity matrix is calculated for the mixed attribute. So it's very difficult to ask in the exam the question based on the dissimilarity matrix, because for that the output is expected to be calculated for the dissimilarity matrix for all the types of attributes. Okay, so in a way, for a sample case, if it is asked like in this case, like as the object 3 and 1, so object 3 and 1, so for the object 3 and 1, the values are there basically. So in that way, for one case it's possible to ask in the examination, but not to calculate the whole matrix basically, because it's a time consuming job. But in that way, what we are expected to do in the mixed attribute calculation, we are expected to take the output from the respective tables, and we are expected to multiply it by 1 and divide by number of attributes, and we get the value for the mixed attribute basically. So in that way, this is about like what? The calculations or like the distance measure calculation for the mixed type of attribute. So this is like the conclusion of the what we have discussed basically. And then the next point is like what? Calculating the cosine similarity. So majorly the cosine similarity measure is used basically and very much popular in the text mining field. Okay, so the specialized area for the data mining is a text mining. The specialized area of a data mining is a text mining basically. So in a way, this is the cosine similarity measure is used for basically when the documents are compared. When the documents are compared, for what? So how many contents in a document, or how much percentage of a content in a document are similar or not. So in a way, like there may be many more applications in text mining, where these kind of similarities are expected to be compared. So for the plagiarism check also, so one of the application example may be the when we upload any of the document for like the plagiarism check, so whether the contents are copied or not. So there basically that application, that may be one of the application for like the this kind of text mining application. Okay, so where the cosine similarity may be used. So here you may observe basically, okay, the here what is basically given. So a document can be represented by thousands of attributes, each recording the frequency of a particular word or a phrase in a document. So in a way, here what it is basically mentioned, this is a data set created after processing, after pre-processing, and where from the document, so these are the basically the keywords, these are basically the keywords like the team, like the coach, like the hockey, like the baseball. So where how much time these words or these particular keywords are appeared in a particular document, so that frequency is calculated, basically. So in a way, in document 1 team is appearing 5 times, in document 3 it is appearing 0 times, then hockey word here it is appearing 3 times. So in that way basically the frequencies are recorded. So this is like what this data set is created after pre-processing, the documents basically. Okay, so in that way, so this may be considered as a input for like the cosine similarity. Okay, then what are the applications? As I discussed, basically the information retrieval, biological taxonomy, along with the plagiarism check, the information retrieval, biological taxonomy, gene feature mapping. So these may be the applications basically for the cosine similarity. So in that way, now how the cosine similarity is measured? So in that way the cosine similarity is measured using this equation, so where what it is basically, so d1 and d2 are two vectors. So here it is called as like the d1 and d2 are two vectors, where they are also called as basically the term frequency vector, because like what we are doing, we are calculating the frequency of appearance for a particular keyword in a particular document. So in that way, here the cosine similarity is calculated using this equation. So where d1 dot in d2 indicates what? The vector dot product, and d represents what? The length of vector d, So based on this equation, now we will see one example and we will calculate the similarity. So for similarity calculation, what we discussed, the same thing is here, it is mentioned basically. So dot product of two vectors, so there it is mentioned d1 d2, here it is mentioned xy. Okay, and the length of the vectors basically as x and y. So here actually it is calculated using the x is calculated. So the length of the vector is calculated based on like what? The square root of the all the attribute values, and y is calculated as the square root of all the attribute values. So in a way, this is the example. From this table only. So where we have considered document 1 and document 2. So x is document 1, y is document 2. So the same thing is given there also. So here what we have calculated basically, so the term frequency vectors, these are like what? These are called as the term frequency vector. Okay, so which is taken from this example, this for document 1 and document 2. So we have copied this term frequency vector as it is for the document 1 and document 2. Okay, so this is the input basically. So if you want, you can write down this example in your notebook. Now the dot product you are expected to calculate. So you all know basically how to calculate the dot product of the two vectors, basically of the two vectors. So here it's 5 into 3 plus 0 into 0 plus 3 into 2 plus 0 into 0 plus 2 into 1 plus 0 into 1 plus 0 into 0. So in that way we are expected to calculate the dot product. So the vector dot product is 25. The vector dot product is 25. Now we are expected to calculate the length of the vector using this value, using this equation basically, that is square root of all the attribute square addition basically, square root of all the attribute squares addition basically. So in that way here we are considering for calculating the x all these values. So in that way it is 5 square plus 0 square plus 3 square plus 2 square plus 2 square. So in that way it comes as root 42. It comes as root 42. And if we calculate the root 42, then it appears as 6.48. So on a similar line for y also we are expected to calculate as 3 square plus 2 square plus 1 square plus 1 square plus 1 square plus 1 square. So in that way if we calculate, it comes as root 17. It comes as root 17 and the answer of root 17 is 4.12. So in that way we have calculated. Now here we are calculating the similarity. We are calculating the similarity. We are not calculating the dissimilarity. Okay. So here similarity is calculated. So the x dot y, so dot product is 25 upon 6.48 into 4.12. So the answer is 0.94. The answer is 0.94. So here instead of square root, they have written as raised to 0.5. Raised to 0.5. So in a way, the similarity is calculated. The similarity is calculated. So if you want, you can go for document 3, document 4. If you want, you can go for calculating document 3, document 4 as an exercise and tell me the answer. The equation which you want to use is this. And on a similar line, so here what we can say basically, the documents D1 and D2, the documents D1 and D2 are 94% similar. Document D1 and D2 are 94% similar. 94% similar. So in a way we have done with all the points for the unit 3, and if you want to calculate the document frequency or like the cosine similarity for document 3-4, you can solve it and tell me the answer in the chart window. And in that way we have done with the third unit. From my part, Google Classroom, immediately I am uploading this PPT now on both A division and B division classroom, that is remaining, and then I will upload one test also, which you will have as a practice test, but the actual test which we are going to consider for like the continuous assessment will be in a specific slot, and that we will share with you. So in that way now I will Before concluding the session, now do you need one more review lecture for the third unit, or should we start with the fourth unit? That input I want from all of you in the chat window. I think we have repeated many times all the things actually from the third unit. So it's not required. So we can move to the fourth unit basically. So that is association rule mining. So I had seen basically Pradeep Patil sir has covered the a priori algorithm, but in what way we are going to cover basically the association rule mining. So as we are more focused on like the algorithm part, so what is the algorithm, what are the algorithmic steps, and in that way we are going to cover association rule mining using a priori algorithm and the FP growth algorithm, basically frequent pattern growth algorithm. So both the algorithms, the algorithmic steps, the pseudo code, and the comparison of the a priori and FP growth algorithms we are going to have basically, and we will start the fourth unit in my opinion from the next lecture. So is that okay with you?